But yeah, be careful disconnecting.
I left that there for me.
Okay, welcome everyone. We got some people in the back. So, thank you all for coming. We truly appreciate all our sponsors and let me first hand out some of the December's sky calendars, and if we run out, let us know. We can send them to you or whatever. Let's see. So our next meeting will be 5 weeks from tonight. And just like
Potluck.
and potluck. And we're going to start at 6:30 instead of 7.
And the date on that, Barbara?
The December 21st. Thank you. Saturday. It's always great food. As you will see in my Mountain Messenger article, I also said, we've never done a meeting that close to Christmas before. So if you're burnt out and you just want to come and do the $5 donation, that's great. And just eat and have a good time. If you want to bring a bottle of wine or a beverage or whatever, that's fine too. Because I know that's close into where a lot of people are kind of worn out by that time. And we always have great food, though. And let's see, I want to also thank Mountain Messenger for running our stories, and also Coal Creek Canyon Park and Rec, who is our sponsor. And Dave has his cards in the back, $5 each, right, Dave? At the very end, I think, I don't know if we have anybody who's never been here before, which is kind of rare because we usually have junior people. But we do a group picture at the end up here. And so we'll have Leonard go first. He'll give a little bit of astronomy, you do the space missions update, and then John will do a little bit of
I
astronomy
think we should
news.
switch tonight, just for the heck of it.
Yeah. And as a part of the astronomy news, Dave Schummel will talk to us about his picture. He got the Mercury Transit across the sun, which I think is so amazing. Did anyone see any Leonids meteor shower? No, we didn't either. Did anyone see? You might. Hopefully, you all got the email about Thursday. We thought maybe that would be like a giant meteor shower, and it was. Yeah, I looked, but it was really cloudy.
That's okay, no. Well,
Nobody saw. Did anybody in the world see it?
Nope.
Okay.
Well, I guess I don't have to talk now.
Yeah.
So you can do that.
Okay, so Leonard first, and then we'll have Brian Enke, who we are honored to have. He has come all the way from in the foothills above Lyons, and Lori, his wife, is right back there. And we're just so grateful for them coming all that way. It's at least an hour and 15 minutes or so.
It's not as
And then
bad
you-
as Carswell.
He used to live
It's
in
an hour.
Ned, so,
Yeah, that was much closer in that.
yeah. So Leonard,
Okay, I'm gonna sit right here because I have too much wine. And we're just trying to run these babies through.
That's the first.
I think, one of the things that didn't get,
Dim the lights. Yeah, back here.
something that didn't get too much coverage in the general space community was Japan Hayabusa 2. This is an asteroid mission. Totally amazing what these guys did. They lobbed robots on the asteroid. They went down 2 times. They sampled the asteroid. They sucked up stuff from the asteroid inside the spacecraft. And what are they going to do now?
Is that
They're
good?
coming home.
Yeah.
They're coming back to Earth. And this thing was launched in December of 2014 and rendezvoused with this near-Earth asteroid, Ryugu, in late June 2018. They did all the work, and they touched down several times, lobbed off robots, and they just departed the asteroid, coming back to Earth, and will land in Australia with the samples in next year, late 2020. And they're pretty excited. So it's a tremendous mission. Did just great. And it really speaks to something else they're going to be doing in the near future, which is actually a Mars Phobos Deimos mission that they're planning, and that looks pretty good. But they pulled off something pretty incredible here. America has got OSIRIS-REx around another asteroid, and it'll be sampling that in the near term and bringing back samples. So, but this one is just watching these folks achieve over and over again some major milestones of sampling the asteroid and dropping robots off on the asteroid is just terrific. Brian's going to do a lot on Mars, but I thought I'd just bring you up to date with curiosity. I kind of NASA's rover on Mars landed there in August of 2012. It's doing incredible work on its own. Right now, it's at different buttes and dunes. I just downloaded these yesterday, I think, and so it's pretty active, and it's continuing to do Mars exploration work, and so that's a success story for NASA. I write a lot about China. Just about a week ago or so, they have a test of their Mars landing system for Mars that will be actually launched next year. And to do the experiment on landing on Mars, they built these several hundred foot tall cranes up in the air to actually simulate a Mars landing with their rover. They're pretty cool, and they had a simulated Mars landing zone on their landing area there underneath the test site. And they just pulled this off a couple weeks ago. They invited the world there. It was pretty odd, and China's very interested in bringing international cooperation into their space program. They invited the world to come and watch this test of their lander. And this is sort of a picture of the lander itself on the left, and what they hope is going to happen next. They'll launch in 2020 and they'll land in 2021. And there's multiple spacecraft going to Mars next year. This is NASA has its Super Curiosity Mars 2020 rover. The European Space Agency has EuroMars. It'll land on Mars at the same kind of time frame. And then you have China with its attempt to, for the first time, land on Mars. Same with the Europeans. Well, the Europeans have tried. But so China's there. And then the United Arab Emirates have an orbiter that they're going to put around Mars in that same time frame. So 2020, 21 is a big deal for Mars. A lot of international folks going to Mars. So we'll keep an eye on that one. One thing that's coming up that you got to keep an eye on, it's pretty important. Again, this deals with China. They've had some booster problems with their Long March 5, which is a heavy lift booster. It the first flight was successful, the second one was not. And they've been working for a couple of years on trying to figure out why it didn't work. Why it didn't work, we're not quite sure what all the intricacies were, but they think they fixed it because they just a few days ago got all the elements of the Long March 5 into their launch site for a third attempt at launching this booster. Why it's important is because it has to boost this thing, a back to the moon concept for return sample. This is one they've already landed on the moon, the Chang'e 4, which is on the left lander. It let loose the U-2 rover, and it's been going pretty strong for, I think, 12 lunar nights now, something like that. It's pretty a long-term far side mission to the moon. So keep an eye on the Long March 5. If it fails, all these other China moon robotic programs are going to be waylaid. So then we get to America. And where are we? Okay, this is a U.S. policy, NASA mission. Artemis is the name of the program. I know most of you know Apollo. This is the name that some people don't even think about anymore because nobody knows what it is, but Artemis is the NASA program to return to the moon. This is 2024. They want to put a first woman on the moon and another male astronaut. That's the goal. One cool thing that's going on behind the scenes, it's kind of, I really think it's cool, is we are opening samples of Apollo specimens that we had not opened previously. We went in 1969 to 1972, we put 12 people on the moon, and we brought all these samples back from the moon. And some of those have never been opened. And so for the first time, a month or so ago, they opened Apollo 17 sample that has not been opened, and here are the three leading lunar researchers opening that casket of samples from Apollo 17. And so what's the point? Okay, they're old news from 1972. They're old news, but being used with new equipment. And so can you take Apollo samples that we've never opened before and interrogate them in a way that have never been done before with all this new equipment that has been developed between 1972 and 2019. And that's what's going on. So that's I love that story. The samples that keep on giving. Okay. We have a little bit of a problem here. Now, Elon Musk is pushing the envelope on a lot of different things, but one of them is the Starship, that he wants to put people on the moon and people on Mars. And he's got great artist concepts of what this looks like, this particular vehicle on the moon. Unfortunately, it kind of blew up the other day. It had a problem. And Elon is just, his point is that if you don't fail, you don't succeed. And so this just happened a few days ago. He kind of blew the top off on the rocket and kind of went, it didn't get to the moon, but he crashed nearby. So anyway, no, this wasn't meant to go to the moon. But anyway, he's working on this Starship, and always keep an eye on Elon Musk. Full of surprises, full of also delays and hopes for getting this thing under control. Last thing, Barbara and I, just a personal thing, we had a great time in Carlsbad, New Mexico. It took us forever to get there. After we landed in Albuquerque and drove forever, and my foot almost fell off the pedal. We got there, and we went with 150 or 20 astrobiologists into the Carlsbad Caves to look and think about underground Mars life. Pretty cool. We had so much fun. And I learned a lot. I haven't written this story yet, but there was some really interesting new data about where is life, if it's there on Mars, where do we go? And the caves were a big highlight, but there's some other surprises of some of the people that were there at the meeting. And I hope to write that up next week, and I should be not here now. It's due Monday.
We'd miss you.
And that's pretty much for me.
Okay, and John.
And me?
Astronomy news.
You guys have any questions for?
No, yeah, no, hope not.
Hopefully so.
I have one quick one.
Yeah,
Did they leave the sample behind on purpose to be opened like a time capsule years and years hence?
they kept some of the Apollo, samples sequestered, not to be open,
Okay.
for just that purpose, that they felt that, decades later, the new instrumentation in laboratories would be more sophisticated and you could actually do better analysis than we could do in 1969, 72. So they did it on purpose, which was pretty cool. Frankly, I think there's a sub-story there, but you're gonna have to read about it.
Thank you.
Go to leonarddavid.com.
Pretty cool what's gonna come out of that.
I tried to sell that story to somebody 20 years ago. They're like, nah, we're not interested.
Yeah.
I'm like, come on, this is cool. So, anything else? If you have questions for me, please ask while we're going along. I got about 10 minutes, but I try to jam a lot into this. So, the first thing is, Dave, take it away. I see it. It's only 175 times.
There it is.
Mercury, that was Tuesday the 11th?
No, it's Monday.
Or Monday,
Last month.
Monday the 11th, it's like 10:30 in the morning, something like that. So it was in the last hour or so of the transit. But I used my Nikon D500 and I used they call live view. And I had my big telephoto with the solar filter, and it was just handheld to the bathroom window. I took some
Yeah, somebody was
because it was
asking
windy
where
and
you
cold,
turned.
and it was actually snowing before that. And I
And
wasn't,
Susie wouldn't let you leave that window open very long.
no, but then the cat would escape, so I couldn't do that. So I'm watching, and finally, there was a break in the clouds and stuff, and I was able to get the shot. Although with this live view, I'm watching, and I'm not, I don't want to look directly at the sun. I've got the solar filter. This is what I did with the total eclipse of the sun. Use this rather than putting my glasses on and looking at the sun directly. So I would do that in focus, and when I would get the image of the sun in focus, I would go ahead and shoot. I certainly couldn't see Mercury until I got it on the computer. So yeah, it's pretty small target. So yeah, that was fun. I was glad I was able to capture it.
So this is just out the window at your house?
Mm-hmm.
And you're
And I did some through the glass, double pane glass.
Oh,
And,
sure.
and then some, I was able to open the window and to get the shot. But it has the image stabilization on the lens. So plus, even with the filter, there's still plenty of light to work with.
How many shots did you go
7 or 8, something like that. Then I was thinking, I should get some cool ones when it's, towards the edge, where a lot of people got that shot. But by then we had some more clouds coming through, so I was fortunate to get that one.
Good job.
Thank you.
And Mark actually got one that he was showing to us earlier.
Yeah, I got
Was
one
that,
also, all of the snow, so it's got it at the very last.
Right on the very edge. Yeah.
Yes, right on the
So, later, if you want to see that, you've got it on your phone. Okay,
We can put it up here too if you want.
yeah.
But anyway,
Yeah,
so,
maybe at the,
yeah, Mark, this is proof that there's planets here.
yeah.
At least one. That's good to hear. So, crappy picture of mine. I took it last night from town. Tomorrow night, though, this is Venus and Jupiter, and it was stunning. So if you haven't seen it, check it out. Tomorrow night, they'll be within a pinky apart. That'll be conjunction.
The west?
What time?
It's in the west, right after sunset. So you'll see them, Venus comes out first. It's the first star that you'll see, and then Jupiter will pop out after that. Obviously, these aren't stars, these are planets in our solar system. But they're not even close to together. They're hundreds of million miles apart. And what's interesting is that Venus is in this crescent shape. So it would be cool to look at a telescope when I had that. We had this burst that was supposed to happen Thursday night. I kind of sent the email out. And this is from Rome. Somebody took this. It was called the Alpha Monoceroid meteors. Huh? Monoceroid. So if you don't know, that's the unicorn. But it's just to the north and, well, toward the horizon of Orion. But anyway, so they saw some things, but what they were, the circumstances of this were similar to what happened in 1995 when there were 400 meteors per hour coming from this tiny little meteor shower. The problem, so they thought, well, the circumstances are the same. Maybe we'll get a big meteor shower. But unfortunately, that didn't happen. This asteroid, this meteor shower comes from a comet that they think is on a 500-year orbit. 500-year orbit. But they don't know exactly, and so it's hard to figure out where it is or what comet's causing it. So that's hence the uncertainty in all this. So unfortunately, it was a big bust, but still cool. It wasn't as bright as that. These are my pictures from the summertime, but I thought I would just share those because during a meteor, the Leonids, the other day, this is from Supernova, and those streaks across the sky, the random ones are meteors from the Leonids, but Starlink crossed in front of the telescope at the same time.
Explain the Starlink.
Starlink is Elon Musk's thing, SpaceX, to bring internet to the world. And so they launched back in May. I talked about it during a meeting. They launched 60 satellites, and they were in a train, and eventually they separate, and then they'll go up into their orbits eventually. But they launched another 120 a couple weeks ago, and they're still together. And the IAU is against it. The company I work for, Aura, the Association of University Research and Astronomy, is against this because this was Supernova, and this is a crossing, and it doesn't look like a big deal, but this was one of their, this doesn't look like a big deal, but they were observing a galaxy, and that this is all the Starlink satellites passing in front, just kind of, astronomers are used to dealing with these. They have software to mask out the satellites, but when you got 120 crossing in your sky overhead, it makes it really tough. And what they're worried about is that this was during prime observing time. And so they weren't able to, some of the science may be lost. Anyway, the astronomical community is going to go nuts over this because they're planning to launch more than 3,000 of these things. Right now in orbit, we only have about 2,000. And they're talking about tripling all that. So to watch this story, it's ever evolving. This is the sun today. No sunspots. We haven't had sunspots for 10 days now. And this year there were 275 days without sunspots. This is not unusual because we're in a solar minimum. But on Monday, I've been writing a blog post for the National Solar Observatory where I work, and a couple pores, little proto-sunspots, they're pre-sunspots, they formed and then disappeared. But what's interesting about these pores is the polarity on them is flipped, like we would expect to see for the next sunspot. So what we think is that keep an eye on the sun because there are probably going to be more sunspots coming. The next solar cycle is, our scientists think that it's starting up, but it'll take more time to figure it out. This is a geological map of Earth, and we have them of the Moon and Mars and Io, Vesta, and now we have one of Titan. So you can see the lakes and the craters. And anyway, this is a big deal. NASA just released this from the Cassini mission and all that this week, which is kind of cool. That's not Titan, that's Europa. The news this week on Europa is one of the icy moons of Jupiter, and it's one of the places that NASA thinks may, because it has liquid water, maybe, that it might have life. And it is tidally locked with Jupiter, which means the same face faces it, but it also gets stretched and compressed, which means, it's got a smooth surface, so they think there's water liquid under the ice. Like a couple of years ago, they found, this was an image from Hubble, this stuff down here is, they think was water that Hubble saw in ultraviolet as Europa is passing in front of Jupiter. But but this week, some folks released a paper. They took images from the Keck Observatory in Hawaii and found water vapor, and that's coming off the ice. So they didn't find liquid water, but they found the next best thing, water vapor. So
What's the difference when it's in the space?
well, they didn't find like frozen water.
So is that frozen, was it ice crystals or is that vapor?
This was supposedly vapor. Back then, Hubble took this image and then they corroborated it this week.
Okay.
So, yeah.
That was very controversial still, that picture, nobody believed it, so this thing with Keck is big news then.
Yeah, Keck, they didn't have an image of it, so I just drew this one up because you're right.
The water, the main thing here is that these discharges, of water coming off that moon is, this is why we want to go there, because the potential for life is, what is it? What's the water? What is the water? Does it have life in it? Are we supposed to sample that, flying over it? What do you think? How should we go about the next cycle of exploration of this place?
Well, I think that putting an orbiter around it would be great. So what's interesting is we have old data from Voyager. Voyager noticed a slight difference in the gravity field, which some scientists at the time, so this is back in the 70s and 77, they thought that it was maybe caused by water vapor in the environment around Europa, but they couldn't prove that, and so they've been searching ever since. I don't have an answer. Bob and I were talking about this before. There's been lots of new.
You mean the magnetic field?
Did I say gravity?
Yeah. So the magnetic field signature from Europa is proof that there's a massive electrical conductor inside of it, which surely has to be a salty ocean. So there is water down there. Is it getting out to the surface and in a way that we can sample and learn about the inside?
And we also have the same situation going on with Enceladus, which is around Saturn, where we've seen geysers of water coming up off that. So stay tuned. It's an interesting thing. And of course, this week, Bob and I were talking about this. There's been a lot of missions proposed, and one of them is like this submarine type thing. I'm not sure if it's on Europa they were thinking about sending that to.
Titan.
But anyway, so yeah. when Alan Stern came about a year ago, he showed us a bunch of images of Pluto, but also this used to be called 2014 MU69, and then Ultima Thule. Thule is was a mythical island north of Britain, and that the Romans knew about, and so this is Ultima Thule is like far off land, far off mystical place. But now it's got a real name called Arakoth. Arakoth means sky and Powhatan and Algonquin, so that they named it that. Just so you know, that's what it's called now.
Hey, John.
Yes, sir.
On the Europa topic,
Yep.
I didn't see the paper, I heard the news headline. Did they find any other gases like methane or carbon dioxide or anything?
You know, I don't remember reading that because they were the articles I read were mostly, I didn't read the paper itself, which is my fault. It seemed like it was all about water, so. Okay. We're still getting, talking about Voyager and Europa, we're still getting information from Voyager. The Voyagers are, if you're curious, they're way out there. About 12 light hours. They've hit what's called the heliopause, where they're not encountering particles from the sun anymore. They're encountering particles from other stars. So they're beyond what we consider our the sun's influence. But what they've encountered, and they released this week, was that we're still getting data, especially from Voyager 2, which has some more instruments that are working. And what we're seeing is like in 2012, when Voyager 1 passed through the heliopause, about this time last year, Voyager 2 passed through this area, is that the density out there is a little more than we thought it was going to be, which was surprising. But it's also much colder, which makes some sense. But it was a little hotter than they thought too, so they think that there's some compression going on, that the sun's influence is pressing against that edge and is compressing the gas and heating it up just a bit. They're very interested in this area only because it's new ground, right? And it's exciting to me that we're still getting information. We're still able to get good science from a mission that we pretty much thought was, we had written off long, long time ago. So Voyager is one of my favorites. So I think it's cool that we can still get that. Just for grins, I put this one up. I found this. The Voyagers are sitting out here at the heliopause. They're not even close to anything like Alpha Centauri. So, like I said, they're only 12 light hours away from us. Alpha Centauri is 4.3 light years, so they're not going to encounter anything. Well, they won't encounter anything anyway, because space is a big place. So, yes, sir.
Point out the logarithmic scale.
Yeah. So just so you know, it's in astronomical units, which is the distance between the Earth and the Sun. So we have 1 astronomical unit. Saturn sits at 10. Obviously, this is not to scale. It's logarithmic, like he's talking about. So yes, very cool. This week, I don't know if you read, but there was release of gamma ray bursts are like one of the most energetic things that we see in the entire universe. And we got 2 this week from this galaxy that's about 5 billion light years away. So obviously, 5 billion years ago or so, some massive objects collided. What's wild about this one is that they've determined somehow that the matter that's being accelerated through at the poles of this thing and it's getting shot out, creating the gamma ray burst, is moving way faster than they thought it would, close to the speed of light. That's why it's releasing so much energy. What I haven't heard is that the LIGO has detected anything. These reached us at the speed of light. Gravity waves also travel at the speed of light. So stay tuned for that. Maybe they'll come up with, we've identified these things, and we're seeing more and more of them, only because we know what we're looking for now, but it's always a thing. This is a big blob, but it really shows the supernova of 1987A. This was in the Large Magellan Cloud in 1987, and they've been looking for the star that is left over, and they finally think they found it, this location of a neutron star that's the leftover piece of this supernova after it blasted itself apart. What's kind of cool about this is that they've been looking for it for 30 years now, and they don't know if it's been blocked by dust and gas. So they now have something to look at here, which is kind of cool. Anyway, that's it.
Any questions?
Questions?
Yeah,
I'll try to answer.
Voyager 2, when it hit the heliopause out there, I read that there were some tremendous temperatures. 89,000 degrees or something tremendous like that. How would it survive?
Because there's not a lot of heat.
Okay.
The density's really.
Density.
I said that the densities were more than they expected, but they're still much less than they're like inside the heliopause. The densities are really high, and then it drops off immensely. But they did see a big temperature rise out there. The plasma is not there. I'm going to get you set up, and then we'll.
Say a few words about Ryan here. Some of you know him very well. He's worked with him for years. But he's a senior space research analyst at Southwest Research Institute in Boulder. And for nearly 20 years, his research at Southwest Research Institute has touched on every planet in the solar system, including the former Pluto. So you do believe Pluto's a planet?
Well, it depends on who I'm talking to. What do you all think?
Oh, no, that's only him. How many people believe Pluto's?
It's not about believing. It's about definition.
How many know that Pluto?
Pluto is a world that's very interesting.
Yeah, okay.
There you go.
But, we had Alan Stern talking here, and he said Pluto is a planet. Anyway,
It's a dwarf planet.
it's a dwarf.
We have a dwarf star, so what? It's still a star.
Okay. So he's worked on the moon and many asteroids too. And he is also a part-time science fiction author. And how much are you selling your book?
I think I'm just giving them away. So
Oh,
if
really?
anybody wants a,
Okay, how many do you have?
not too many, I think there's about 10 of them.
Really?
8 or 10.
8 or 10? Okay. And Shadows of Medusa, which is area of Mars. And maybe at some point you can say a few words about the books that
I will, because it's going to factor in a little bit of
what you're talking about. He's also been a long-time high school robotics mentor, and he's the local chapter for Mars Society, the Contact. And as I mentioned before, he and Lori have come from far away on the foothills on the other side of Boulder.
almost as far as Mars.
We're very honored to have.
And
both
you
of
saw pictures of him when I gave my talk on the Mars.
Oh, yeah, because they were in space.
Brian is one of the guys also testing them out.
On the Barker Reservoir.
Yes.
Yeah.
Also known as Mars, if you make it a little bit better.
Great.
So thank you. Thank you, everyone. This is going to be a little bit different of a talk than I usually give. I hope it's a little bit more fun and a little bit more interactive.
And can you
Okay.
hear? Yeah. Good.
So I mentioned some of my background, and we've had other speakers from Southwest before, so I'm going to kind of skip a little bit about, my first part about what Southwest is and what we do. what I do there, I have worked on a lot of science missions, science projects, as mentioned, pretty much touching lots of the solar systems. And it's always been a challenge and always something new. Bob and Clark have been involved in some of those studies, and so thank you. I'm very honored to have helped out with that. I'm a computer guy in my background, so I do a lot of data analysis, done a little artificial intelligence work in the past, just various computing type things. What I'm doing right now, I'm actually the lead science pipeline engineer for the New Horizons missions. So those beautiful pictures of Aerocock that you just saw, they came through my pipeline. I was probably the first person to see them. Really excited too. Still amazed at it all. It was quite a challenge. And when you're maneuvering a spacecraft by its own camera out in the Kuiper Belt, over 4 billion miles away, and Alan probably hit on a lot of this, it's not easy. There were 1,000 things that could have gone wrong, but they didn't. Most of them did. I am a part-time science fiction author. Mars is my favorite stomping grounds when it comes to writing. The talk I wanted to give to you tonight is more fiction-oriented. I'm not actually going to talk much about science. In fact, I thought I was going to get away with actually not saying anything about water on Mars, which is like unheard of. Whenever I give a talk, it's water on Mars, geology on Mars, all this stuff. But it turns out there is one slide that is water on Mars, so I apologize. I have a sequel to Shells of Medusa that is pretty much done. It's not released yet. It's only going to be on Amazon as an ebook called Medusa Rising. And there will need to be another one after that, too. So it's part of a series. Everything's a series nowadays, so I apologize. Yeah, there's a little bit more about Southwest, but again, I'm not going to go on that, other than to mention we've seen Curiosity. When I've had some pictures. And you did mention that in 2020, NASA is going to launch we call it a Super Curiosity. It's mostly the same, but just newer, better, different goals, and a different location. So that will actually show up in the slide too. We're looking forward to Curiosity and anything to do with Mars rovers. Wait a minute, I'm slipping more into a science train of mine, and I want to be thinking fiction. So, yes, to speed things up, we are going to skip the part about getting to Mars. And as I said, we're going to skip most of the science, most of the geology. Let's think about fiction, and let's think about what it would be like to live on Mars. I thought that would be a really fun topic. And we will get there someday, I hope. You know, the alternative is worse. So
Extinction.
yes, exactly. Really, as I see it in my, when I get all philosophical, it's really a choice between extinction and spreading outward. And might as well not even blunt it. That's just what it is. There's really no other choice. So we'll get there. So let's be optimistic. So we're there. Wow, that was easy. So welcome to Mars. Right now, today, population is 0. Nobody's living on Mars that we know of. Well, okay, we think nobody's living there. This is one of the places on Mars. I just kind of picked it at random, although I've had a couple of high school students a few years back that did a settlement study about Mars, and they used Aram Chaos as a location. If I had my globe here, I could kind of show you where it was, but it's kind of near equatorial. It would make a pretty good landing site in several ways. It's about a 250 kilometer wide crater. Does that sound about right? You probably know more
Yes,
than that.
it's
It's in that. Yeah, it's in that region. Probably very water rich, very diverse. But so if we if we want to think about living on Mars, location is, of course, very important. But that's getting too sciencey, so move on. Because we're actually there. And here's the picture Dewey was talking about. Cool. This is our selfie. So we're there, we just took a selfie. There we are. Oh, and now we took another selfie. Except that's not actually us. I think that's people out at MDRS in Utah. They're actually doing geology and they're trying to figure out probably something about the layering of the terrain, we'll say. Because 4 billion years ago, we go in our time machine, Mars maybe might have looked something like this. This is a picture off the NASA website. It's actually Jezero Crater, which is the landing site of the 2020 rover. So that's where we're coming into the rover. That's one of the reasons that they picked this region to land the rover next year, is they want to learn more about what Mars was like 4 billion years ago. So, and that's great. You know, I don't want to knock that at all. There's amazing science that's going to happen, and it's going to be amazingly interesting, but that's not a topic tonight. And so I'm wondering for tonight, well, why do we spend so much time wondering about this? And we could spend more time wondering about that. What about the future of Mars? So let's think about the future. And here's my first question. I'll have a few questions for you because we're going to march through the world of literature or movies or whatever about science fiction. So does anybody recognize this? What is that from? It's Star Wars.
What reminds me of is Artemis.
Artemis.
Artemis is on the moon now.
True.
Yeah.
No.
Maybe Star Trek?
Don't
Houston Astrodome.
you know, I think it might have a name that I don't know about, but it was always just called the World City. But does anyone know where it's from?
Foundation?
Foundation series.
Ah, you're a step ahead of me.
Supposed to be one. Supposed to be one.
No, this is not Trantor.
Thing covering everything.
Yeah, like 2 or 3 stories.
That was going to be where I was going to go next because I want this to be Trantor.
Okay.
So for those of you who don't know Trantor, my favorite author, one of the reasons maybe I started writing science fiction is because I really like the style of Isaac Asimov and his ability to work science into his stories in a way that didn't detract from the story, that could really entertain the reader, and to really get deep, and then to really smack you on the head at the end of the story. I just love his style. And this is his world city, Trantor, in his series Foundation. It's basically a city that covers an entire planet. And there's trillions of people living on it. Well, who knows? I didn't think he mentioned the population. So, what does this have to do with Mars? Well, if we're being really optimistic, and Mars, given its location close to the asteroid belt, it could potentially be a very mineral-rich environment 1,000 years from now, or 10,000, or however long it takes. This could be Mars someday. The terraformers would have something to say about that. There are different directions you can go with Mars if you look into the future. But anyway, I need to find somebody then. I think Bob, you were, no, actually, Steve, you were talking to me. You came up with Trantor first. So you get to hold on to Hug Mars first, okay? So hold on to that, but you might not have it for long. You know, 1 trillion people living on Mars. You know, this is science fiction. This picture, by the way, is actually Star Wars.
I said
Star
that.
Wars 1. Oh, you did
I said that.
Okay. Yes, that was the world plan. I think it's in Star Wars 1, which was actually the 4th Star Wars. So, I like Trantor better, though. I'm not, well, Star Wars is okay. But this is hard to relate to. You know, 1 trillion people living on a planet when right now there's nobody on it. Well, so let's go, thinking about what it's like to live here is hard. So, what about 100 years from now? Okay, Bob, you might lose your hug of Mars. Does anybody recognize what this is from? I'll give you a hint, it's a movie.
Total Recall.
Yeah.
Very good. This I thought was a tough one.
Don't hit anybody yet.
Because in Total Recall, the Arnold version of Total Recall, you see Mars as sort of a backdrop in a lot of scenes, but it's never really called out. Other than there's a couple scenes when they're out in spacesuits and all. I try to skip those. They're not very exciting. But this is always kind of in the background, as you see it through large windows and all in your settlement, like when they're in a hotel or they're in a restaurant, things like that. That's how they're living on Mars. I'm guessing that maybe there's 1 million people that are living in this city on Mars. It was big, and most of it was underground. And so because it's underground, you really don't know how big it was. But it's big enough to have all these real interesting intrigue plots and subplots, and well, if you saw the movie, you know what I mean. So we'll say 1 million. Quanto, yes. What was it? Quanto lives. Quanto lives. What was the slogan that was sprayed everywhere? Quanto lives. Or Bubbles. But this is still hard to relate to. This is too far in the future. So, what about 50 years? Next chance for the hug of Mars. Where did this come from? And this is a harder one, unless you...
Is it on Mars?
Theoretically, this is actually a Mars study that was just done recently. So to give you a hint, this is not a movie. This came out of a group from Poland. No, still no takers. The Mars Society just had a big settlement contest.
You're going to wear high heels on Mars?
Someday. Remember that light gravity, you just float in your high heels. Yeah, very stylish motions. So the goal of the study was to propose the architecture for a Mars settlement that could house about 1,000 people. And it was kind of ambitious in that it had the teams look at different aspects of the settlement, like the economy of the settlement, the politics of the settlement, how they're going to grow their food, pretty much everything at a high level of detail. And there were some really good entries. In fact, I was one of the judges for 2 of the rounds of the competition. They had to have 3 rounds of the competition because there were 100 entries. And some of them were quite good. Some of them were,
Hey, Brian,
there were some very good ones.
what are the politics? What's the where do you have to have an autocratic rule to have a base and live versus when do you start having a representative democracy? Is it 1,000 people or is it less or more?
That is a great question. And I wish I had a great answer. It is one that is debated.
Just tell everybody what to do.
So you have different phases of Mars settlement and different numbers of people. You might have multiple settlements, so that can factor in how many settlements you have, can factor in with the type of government that you have on Mars someday. Initially, if you're on an early mission, I tend to think you really need to be autocratic. You need a strong mission commander that can make a decision on the spot. Yet the psychology of it, I get into this quite a bit in the book actually. I have a 3-person crew in my novel, and it's very autocratic. There is a mission commander who's former military, and what she says is her way or the highway. Yet the other 2 crew members, they want to have their opinions, acknowledged too, especially since my main character is one of the other crew members. So there's all kinds of nuances when you look at the command structure. And it would have to evolve this point of about 1,000 people. If you think of a city on the Earth, a town on the Earth, this is sort of like Netherlands, say. And so would you be able to use?
That's scary.
Yeah, I know, I intentionally,
I've never seen that in Netherlands.
Maybe when they get to
Especially the
downtown
heels.
redevelopment.
Yeah.
Keep Mars weird.
When you, yes. I used to live in Maryland, by the way, and Lori and I, we escaped. We love Maryland. Yeah, we actually love Maryland. It's very, it's very weird. It's very eclectic. But when you reach about 1,000 people, maybe it's 1,000, maybe it's 10,000. Again, like I said, it depends on how many settlements you have too. You're going to want a different style of government. And that was a big part of this Mars Society contest, was to get ideas from people about what kind of government might work on Mars, what kind of culture might you find on Mars, what type of people are you sending there, just all of this stuff. Anyway, this was actually not the winner, it was second place. It was a group over in Poland. The contest was won by a group at MIT that submitted a proposal that involved basically hollowing out a crater wall. So you have a kind of round settlement, it looked like a donut, with some manning facilities in the middle of the crater. It was very well done. And actually I'm proud of that one because that was in my initial group of entries that I was judging, and that was the one that I picked out of that group that was the best. And it went on to win, so yay. Anyway, so maybe about 1,000 people, but still too hard to relate to that. I mean, thinking people on Mars, that might not be your initial vision of what it would be like to live on Mars. So how about, let's go 30 years into the future. And 30 years is a really interesting time because here you start to diverge between different plans, in particular a private enterprise plan for Mars and a NASA plan for Mars. They will end up looking quite different. So this was a study, is private enterprise, is a group called Four Frontiers. And they did a settlement study about how they could build a settlement on Mars that starts with 12 people and then expands, self-replicates, so that you can have about 100 people. So let's say about 100 people on Mars. Basically what you would do is you'd start out small and then expand the base around a hillside. They call it the hillside base. So as long as you had enough reason to expand, it would look like the opposite of the crater colony that I said won the competition, which was a donut with a crater. This is a hillside, it's a settlement around the hillside. So the point being that you want key parts of your early settlement to be underground. Right in here, these are little skylights and some of the command and control parts of the base, the dining hall, things like that are going to be underground and shielded just in case you have a bad solar flare ruining your day on Mars. You want to have some place to go where people can have a little extra protection. A lot of surface elements though, greenhouses. These are actually apartments where people live. And you want big windows with overhangs. They don't show the overhangs. Anyway, so that's about 100 years. But if you happen to be a wealthy optimist whose name has only been mentioned about 5 times tonight, which was, oh, I just ruined it. That was going to be my next question was, who thinks that 30 years from now can be back? This person's plan for Mars 30 years from now has about 1,000 people in it, maybe more. And of course it is SpaceX. And Elon, one thing you can say about Elon, love him or hate him, he never does anything small. He has big ideas. And he's building the rockets. If he can get his Starship working in 5 years or so, he might be on his way. I don't know. I wouldn't put it past him, but this does look a little optimistic to me. I'm usually an optimist. That's a little bit farther than my comfort zone. I like the previous one a little better. This, I think, could happen. The Four Frontiers study went into a lot of detail about manufacturing processes, where you get your energy, where you get your food. There's been a lot of studies over the years. This was a really good one.
Do the red roofs have radiation shielding?
Radiation shielding, which part of the base were you?
So people are living in those little houses and the roofs are red. Is there like water or some kind of a lead or something to prevent radiation?
Yeah, I think they have some water built in, they have some layers of brick and other hydrogen-rich, it could be, hydrogen-rich material basically is what you want. And as I said, what you really want is overhangs too.
For radiation.
For radiation, yeah.
That's sponsored by Red Roof then?
Yes.
Is that the deal?
Yes, although I like to say that when NASA reaches Mars someday, they're going to check into the Hilton.
Yeah.
So I'm thinking more Hilton than Red Roof Inn, but that works.
So what's the mechanism for population growth in this one?
Population growth, another very interesting topic on Mars. We don't know if people are going to have kids on Mars. We don't know. Someday we'll find out. So regulating population growth initially would be just however many people you're sending from Earth.
So they're not making their own, because otherwise it would be a pretty small genetic sample.
You want to at least picture people if you're doing that, but you're constantly going to have an influx of people from Earth. I think that's the assumption. It's not meant to be a closed environment in terms of people. So, yeah, that's a good question. In fact, yeah, you could go very deep on that topic. Especially, if we're going farther ahead into the future, and getting more and more people on Mars, where are they coming from? Most of them are probably coming from Earth, at least initially. And then later on, who knows? Once you reach this point, they're going to be Martians. They're going to do whatever they want to do.
Well, I mean, people make babies, so.
Yeah, exactly. They're going to do what they want to do. So, yeah, they'll figure it out. So we talked about Elon. Or if you're a scientist and the science is everything that's important to you and you don't really care that much about the habitation part, then 30 years from now your Mars might look like this. So next chance for the Hug of Mars. This is from a movie, although it's really not a scene in the movie. It was like the set that they put together for the movie, but that's not a real astronaut.
Martian.
Oh, yeah, okay, I don't know who's going to get the Hug of Mars on that. Yes, this is the Martian.
It's pretty close.
Yeah.
The Martian.
Who's going to have it? Nobody wants it.
Nobody wants that. Okay. Yes, this is the Martian. But, as in the Martian, watch out. Warning, this is probably a deadly trap. Because if you like science, this is probably the way to do it. You just don't worry about the settlement stuff and just do science on Mars however long you can until your budgets get cut or whatever. But if you want to do settlement, and if our goal on Mars is really to have all these later settlements that we've just seen examples of in Hollywood, books and all, 1,000 people living there, 1 million people or whatever, this might not be the best way to do it. It could work. This is the NASA plan to do it. NASA wants to send 2-year missions to Mars. They might overlap, so maybe your people might stay 4 years. There would be a series of them, at least 4 or 5, maybe 10, 15, however many they need in order to characterize the science at a location. And their assumption is that you need to know that science before you can send people to live there. When in reality, that's actually a pretty shaky statement. There are certain things you want to know ahead of time, but there's a lot that you can figure out once you're there too. But the real problem is, again, this is really our goal. What is the fastest, safest, cheapest way to do it? And the settlement first part, the problem is, I'm looking at it from the point of view of a systems engineer. Oh, I forgot that, by the way, in my introduction. I used to work at Bell Labs. I worked there for 20 years. We did telecom systems engineering. and we were the best in the world at it. And that was a previous life for me, and I kind of, I don't put on my quality hat very often, because this space and space science is so much more interesting than quality work. But if you're planning a Mars settlement or a series of Mars missions, you have to pay attention to things like quality, risk analysis, things like that. And you need to let the science drive that, the quality science, the things like PQMI, stuff like that. You have to manage your risks that way, or else you're going to exaggerate the risk. And the problem is that this science first sort of a mission plan, like NASA has in mind, you load up all your risks up front and they're cumulative. Because if any one mission fails, in fact, it was just mentioned earlier tonight, if any one mission fails, well, what's going to happen? You know what's going to happen.
NASA's job is not colonizing Mars.
Exactly.
I mean, and it's not even science.
Exactly.
NASA, not a science agency. Right? NASA's job is doing cool stuff.
Yes.
And if putting people on Mars and having them be able to live on Mars and do whatever, if that's cool, and if there's a budget for that, they'll do that. If suddenly this planet decides we need to colonize Mars to survive, then NASA will be in the colonization business. So I feel that you're mischaracterizing NASA by saying that they're only doing science. That's all they can do.
No, that was actually where I was going with this. I was leading up to the point that colonization is not a priority at NASA right now. Maybe it could change in the future. I don't see it changing. Maybe you do. I don't see that changing because the politics would get involved.
Well, to me, this
NASA
is like all
an
governments
extension of the government.
versus Elon Musk at the bottom. That's Elon Musk right there, right?
Actually, it's not. It's a different one. That's actually Mars 1. But
No, I'm saying he's the only person who's going to do that. Elon will just do it. And everybody else is a national government who is constrained with their budgets, who will just eke it out, if at all.
Fair enough.
Eke out science?
But the
Eke out
question
trying
here
to
is-
put anybody on Mars
Yeah.
while we're still alive.
Well,
Yeah.
I've got some younger people here.
Oh,
Yeah.
yeah.
The point being, though, that the way you do it really does matter. And if NASA was interested in actually the settlement part, they would not have the current plan that they have. So I think we agree
Okay, I
on
get
that.
it.
Yeah, okay, good, good. And the reason why is a systems engineering reason. Because you have to manage your risk in a certain way. And the easy way to think about this is, okay, let's say NASA all of a sudden is given this mandate somehow, magically, to say, build a settlement on Mars, yay! They would not want to do that first, because even if your settlement was a 100% chance of success, there were no risks that were not totally mitigated, which is of course impossible. Your risks are driven by this, if you do that first. So that's the problem, is if you do that first, and then you do that, then your risks accumulate over time. Whereas if you do only this, you distribute the risks, and you just pretty much one-time risks.
And much bigger.
Settlement first sounds very cool. However, it also sounds like a recipe for casualties.
Yes.
Like there will be casualties. Like
Yes.
one of the
Which is another
10
reason
will
NASA
fail.
can't do it.
Yeah.
Yeah, that is the other reason that NASA. In fact, there are 4 types of risks on Mars mission that you have to worry about, and they get jumbled a lot. There's a risk that one of your 4 types. Yeah, there's a risk that one of your astronauts is going to die. There's a risk that all of your astronauts are going to die. There's a risk that your mission will fail, and there's a risk that the program will get totally canceled. And this all ties into what you said.
Right. Yeah.
Yeah.
Oh, the death doesn't even have to be on Mars, it could be on launch.
Yeah, any death at NASA is going to be a big deal. With Elon, we'll see.
Yeah.
There's probably a little bit more tolerance there, but I don't know. We'll see. Because it's going to happen.
Yeah. A lot more tolerant, I think.
I think a lot more tolerant too, yeah. But that's really important. It's going to happen. I mean, Mars is dangerous. There's no way you can make it zero risk. And in fact, I brought my skunk dice tonight, but I think we're going to be running a little short on time. That's the way I like to talk about probabilities. It's basically you're rolling the dice on both of these missions, and if you do the NASA approach, you roll the dice one way. If you do a private approach, you roll the dice a different way. And at the end, you see which one wins, because it's a dice. It's all random. So, anyway.
So settlement first is kind of like a Roanoke or an early Jamestown kind of a approach.
Yeah.
You send a lot of colonists, some colonies fail, some succeed.
Yes. Yes, that's one way it could be done. And statistically, that is a very good way to do it. It's worked in the past.
That's how this country came to be.
Yeah.
Two things. So, first of all, I know that a lot of people on Earth want to go to Mars, but after hearing that there is no guarantee that their colony will succeed, how are they going to convince people to go on there? And second of all, if we're going by Jamestown standards, how do we know they won't start some sort of revolution and be all like, deal with it?
They might. Yeah. They might. Yes, very good points. They will go, and they might have their own revolutions. That gets into the politics we were talking about. Until you have people living on Mars, we could look into the future and try to think about what it's like to live on Mars, which is the whole point of the talk, by the way, to talk about all this stuff. But until we're living there, we don't know. We're not there. So yeah, all of those are definitely possible. So let's start thinking like a Martian. Well, let's keep thinking like a Martian, because we're doing great here. We're coming up with all kinds of
radiation.
So we're in this early settlement, and it is a highly redundant environment, and you've got some underground parts. Basically, you're sending an initial set of people there, and they're sent there to live, and the main priority of the settlement is your survival, basically, as with any settlement. That's one of the key differences, by the way. In a science-driven mission, unfortunately, you have some conflicting priorities, because your main goal is still going to be survival, but you're always going to have other things going on. So let's say that we're focused on survival, but what else is he thinking about? And what is that? What does survival look like to an early Martian? In fact, one thing might be, I'll start you off, the solar panels. Well, first thing is, he's outside, and he's wearing a spacesuit. Mars is a very hostile place. So he better be focusing on what he's doing with his spacesuit, right?
Don't pepper yourself.
Or else he's going to be a dead Martian right away. Yeah. What other things might he be thinking about? He's probably out there for a reason, right?
So what if things break? Where do you get the parts?
Yep, repair. That's a big one. In an early settlement, you're always going to have a limited repair capability. One of the really cool technologies that's been coming along on Earth lately in the last 15, 20 years is 3D printing. It holds a lot of promise for Mars. It can actually, it's one of those technologies that could end up making all the difference.
Could you explain that a little more to some people, like where, I
3D
mean,
printing.
maybe a lot of people have heard about it, but just what would you print on those?
Yes, well, there are some things you can print, some things you can't. The interesting part about it is that with 3D printing, you can make parts in an additive way. We call it additive manufacturing, as opposed to having to use more energy-intensive ways. So basically, 3D printers, probably a lot of you have seen them. They're very small. They don't use much energy. What they do require is some resources. They require feedstock, they call it, or print stock. And so as long as you have a supply of certain resources, you can feed your printers, and you can use your printers to make all kinds of equipment. Simple things like wrenches, possibly even complicated things like simple circuit boards for computers, electronics. Couldn't build too much there with current technology, but you can build very simple things.
So Brian,
These are the things that could break in a Mars base. You want to have a way to replace them.
so Brian, can you put plastic or metal, or what is the feedstock?
Yeah, feedstock can be different plastics. They could also be different metals. There are 3D printers that even print rocket engines. There are a couple of companies that are test firing rocket engines now that have been printed. And so that's definitely a high energy sort of an application. So yeah, it's very flexible. And then there are also, of course, CNC machines, which is another technology for creating parts. You know, a small CNC machine would be great to have on Mars too, because you can create certain parts with that you can't 3D print. So there are new technologies basically, and the repair one is big. And so yeah, that's a great thing. What else might he be? Oh,
So what about a giant printer where you print your structures?
yes, giant printers. They're looking at that on the moon actually. There's people that are speculating, could you print your whole base? Or on the Earth, can you print a house? There's people working on it. It might only be 5 years from now before you can print a house, although I can look at that and see all kinds of complications. It can't be easy. But there are people that want to do that on Earth, so yes, you could do it on Mars as well. In fact, it would be easier on Mars.
Could you print it before you get there?
You could, although getting to Mars, the hard part is landing. So anything you print ahead of time, you'd have to land, so it might eliminate some of your benefit there.
No, I meant have it printed on Mars before humans get there.
Oh, yes, remotely printing things, absolutely.
Play catch.
Absolutely. Although you have to keep in mind though that you have to feed material into these printers too, so you have to totally automate that. Harder than it sounds, but you can do it. You can do it. A lot of this stuff, the idea with several of the early settlement plans is that you land these and then you have robots, like this big guy, that come along and latch on and construct your base, sort of like Legos. You snap things together and you have your base before you send your people. That's a critical point. So anyway, yeah, he's got lots of concerns. I thought about a few of them. These solar panels that he's working on. An early settlement-only base differs from the NASA route because you might be able to get by at first with solar power, not have to bring nuclear power to Mars. That simplifies your early missions incredibly, if you can do it. But you're going to be power poor then, so there's trade-offs. So definitely your Martian is worrying about power. Worrying about water, although we know where all the water on Mars is now, right?
It's deep.
It's a place.
Although,
It's a place. That's where the water is.
place. Mars has water in different forms. In fact, there are 5 forms, but that's a different talk. You wanna have plenty of water. Food. So food is really ecosystems. You want a closed environment life support system. So you can grow food and recirculate your air at the same time, probably. So that's a big concern. Along the air supply. We mentioned repairs. So I think you get the other ones. Viruses. Early on, medicine, if your settlement is really small, you're probably okay because you don't need a whole lot. But you don't want your people getting sick. There are some Mars-specific health risks as well that you have to worry about. So yeah, health is a good concern. Remember, that's a key difference between, well, I wouldn't say it's so much that that's a difference, because even on a science-only precursor mission, you want to keep your people healthy. So that's pretty standard.
I was gonna say down the line, mental health, and even corrections, all those issues would be there.
Yes. Yeah, mental health is a huge issue with any type of mission to Mars. You have a limited number of people, a limited amount of space. You're kind of cramming everybody together into a tin can, and they're going to explode. You just want them to explode creatively and not destructively.
Pre-screening would help with that.
Yes. Pre-screening, NASA puts a lot of effort into screening their astronaut candidates. It can seem a very draconian process. We have a person in the office who's gone through the astronaut training process and didn't make it a couple times, I think. And yeah, you know, it's important. Pre-screen. You also pre-screen based on health factors. The more we learn about genetics here on Earth, you can pre-screen for a lot of genetic conditions that could affect you later in life. That would be a factor. So who you send to Mars is critical.
I don't want the shining.
When you're talking about repairs, and with repairs, people are gonna get hurt, and that's part of health, but when I was in the first case for Mars meetings, we had a lot of discussion about emergency health and what happens if they die and what we do with them.
Yeah. Yeah, how do you handle that? That hits the health, that hits the function of the base, and that hits the psychology of the survivors. So yeah, that's a big one. It's going to be tough. It's not easy, but fortunately, especially if you're Elon Musk and you have grandiose plans to expand right away, you will grow your numbers quickly, and it gets to be less and less of a problem. But it will always be a problem, just like it is for us today here on Earth. Poker night, of course. And by that, really, I'm just being, I'm getting at some of the psychological factors, like we were talking about. You want to keep your people entertained and happy. Any way you can. Psychology. So, what about going like 30 years into the future? So now I'm working on a backwards, actually forwards, into the larger and larger settlements. And we can go kind of quickly because I'm not sure how much time we have.
Another 10 minutes or so?
Okay. We'll see what we can do in 10 minutes. So for, say, 30 years from now, and you've got this settlement, let's say that you're in the 50 to 100 person stage. That's kind of that next step I was talking about where, you know, you'll still have a lot of impact if somebody dies, but it won't be quite as bad as if there's only 4 people there. One person out of 100 is still bad, but it's not 25% of your population. So you've got someone living in the habitats there. What are they worried about? In a settlement like this, you have a few different concerns than before. In fact, I think on my next slide, as I was listing things, most of those early concerns are still there. You still worry about repairing things. You still worry about your food. You still worry about your air. I think it might be a little different though.
Inbreeding. That's what I was thinking.
Possibly, yeah, we talked about the production part before. But that might not be a problem yet, because the people you're sending to Mars, you might even be sending married people someday. You know, genetically, you're going to be able to have a diverse genetic population at this stage. But a few years later, you go a generation or two, and that could be a problem. So a lot of them are the same, these are my choices. But instead of solar power, here's where you're going to want the nuclear power. And that introduces a lot of other issues. In this settlement concept, if you notice, they've got these buildings over here that are kind of tucked away off behind the mountain. They would really be farther away from that. That's kind of where you want to put your nukes, limited power. Because if this settlement is growing, you're constructing things, and that takes a lot of energy. So that's where solar power becomes a little bit difficult. You just don't have enough power. So nuclear is better. Or, who knows, you know, people are dreaming up new energy ideas all the time. You still have poker night though, that's the important one. You gotta have poker night, as a concern. You're constructing things. It's a job site. You have construction delays and frustrations. And my foreman is a real jerk. So construction stuff. This size of a mission or a settlement, you could be doing some really good science. So you have perhaps a lot of science activities going on. You have deadlines. You have all of the science concerns you know about so well. And that's not to say that you couldn't be doing science all along. Of course, you know, I'm a scientist, you know, we want to do science. A lot of it you'd have to drive from Earth. There just wouldn't be the people on Mars to locally do the science until you reach this step. So you do it like we do right now.
Why is nuclear power such a problem?
It's the construction aspect, because you're self-replicating your base. Oh, why is it a problem to have it? Yeah, what's so bad about it? Well, it's not bad, you know, it's good. It's just a human-intensive activity. Plus, it's got a few extra dangers associated with it. And you've got to really take care of your nuclear, you know, your equipment. You don't want a meltdown on Mars. So it's just normal.
Homework, do you mean future thinking about settlement?
No, because maybe you do have some kids in the settlement at this time, so you could have kids doing homework. In fact, that's another one of the books I got. It's Tales of Life on Mars. It's a series of short stories, some excellent authors that we got involved. It's basically, it takes place in this settlement. This was the settlement that was used as the guide for the book. And there's a family living on Mars. They have things like homework. One of the kids, she likes to do science experiments. It's, yeah, homework. Okay, what about our 1,000-person population? What are they thinking about? What's it like to be a Martian if you had 1,000 people? Again, probably a lot of those same concerns, but not quite so much now on some of them, right? Because you've got 1,000 people, you've got a big city going. You've got a lot of agriculture. Things are looking a little more Earth-like now, aren't they?
So the politics come in now, and government.
Bingo. Hug a Mars. That could be one big difference. You can keep that going. Yeah, that could be a transition. And we talked about it a little earlier too. I think Bob brought up the question about, well, what do the local politics look like? And it really depends on how many people you have and how many settlements you have and all of this stuff. We're just guessing at right now. Until you're a Martian in that situation, you're not going to really know for sure. I keep saying that, but that's really how it is.
What about return trips for some folks? Quarantine, all that kind of stuff?
Mm-hmm. Absolutely, yeah, I should have put that on there. Actually, if we go back to this settlement. See, the idea, you know, when you do a settlement mission like this, you remove a lot of risk by not returning people right away. But you're going to want to build up that capability as fast as you can. So somewhere between this and that, yeah, you're going to add launch concerns. You basically have to build a small Cape Canaveral on Mars. That doesn't sound very easy. Part of that construction is going to be related launches.
So how do criminals in law come into the Mars colonies? How would they deal with that?
Great question. We've been assuming all along that everybody is playing nice. At what point does criminal activity come into play? It might be around that 1,000-person point. It could even be earlier. One of the short stories involved somebody from Earth coming in on the latest, mission. He was the latest colonist, and he wasn't who he appeared to be. So it could happen even earlier. But yeah, when you have a settlement of 1,000 people, you might need some law enforcement. That's a good one. I missed that one. That's good. So here again, you still have your nuclear power, but you probably have a lot more diverse power supply options. In these settlement studies, there were a lot of different ideas, some of which were more feasible than others. And when it comes down to it, nuclear is going to be your most reliable choice, by far. But you don't necessarily want it to be your only choice.
So there's talk of bringing dogs or pets.
Dogs and pets.
For psychological help, of course.
Family, yes. They actually have a couple of pets. You saw my dog fur everywhere down there?
Yeah.
Yeah. Pets are nice, and we enjoyed writing about them and working them into the stories and all, but practically, could you have pets on Mars?
Expensive.
I think
Have to
maybe goldfish.
You have to be very cautious that their brains wouldn't.
Yeah, well,
It'd be weird for them.
if you wouldn't want your pets to get outside.
Might
No dogs.
be specific.
Sort of like genetically engineering.
So by the
pets.
third or fourth generation, you ought to have enough exploration going on from where you live that you've discovered something living that was not within the perception of living when you dropped into stuff.
It's sort of like a native life form.
Yeah.
Okay.
That
Well,
would be the best.
it could be if it's there.
There's probably no such thing.
Yeah. Well, it's a bit of a stretch though from what we know about Mars. The surface environment is so hostile that life would have to be very different than before here in order to survive on the surface of Mars today. It's possible though. Well, science fiction author, I'll write a story about it. Could happen.
Your analog of Netherlands being a good example of, the population of what we're talking
Size,
about here.
yeah.
Very much so. For example, Netherlands currently has a mayor who is a space scientist.
Oh,
the
I
very
didn't know
sort of
that.
person that you would expect to be on this sort of a mission. And he's currently fighting off recalls. So all these, this is, really analogous.
That's perfect.
To carry that analog further, Netherlands doesn't want to be part of Boulder most of the time either. So at what point here do we shove off and tell Earth, go away, we're going to be our own colony? Is it now or is it the next step?
Great question. Yes, that would be my quick answer with that is how self-sufficient is the settlement? What is the point where you reach self-sufficiency?
Yeah.
And most of the settlements were almost there. But if they were entirely self-sufficient, they'd be very fragile. You probably need to be, I would guess, really who knows? We're all guessing. My guess would be maybe a little bit bigger than this. Maybe 5,000, 10,000. There's a lot that you have to cram in. There's a lot
Self-sufficiency
related
on
to-
Mars is tough.
Yeah, that's tough. Although that's where that 3D printing concept really shines, because that could speed things up quite a bit.
But you'll be having a hard time 3D printing medicines that you're going to.
Yes, and advanced electronics.
Yeah.
Those are two of the big ones. But if you produce exports that you can trade for those things, that counts. Someday that will count when you get an economy. Yeah,
I
John.
always think of Antarctica for comparison, that's still not self-sufficient. And for instance, what do they do for power down there?
I don't know.
Diesel.
Diesel. Okay.
Wind's pretty
Yeah,
good down
that's
there.
the kind of.
They have some wind generators there, but they have diesel as the main.
Diesel. Wow.
And there's
My
no
question to you
production.
is, in your projecting, when a society grows and it loses the original component mission, we're all in this together thing, as it enlarges, eventually there become splinter hermits. We are familiar with being and knowing them in the mountains. At what point
I resemble that remark.
at what population size do you see there being splinter elements breaking off and making little mini groups, taking with them what they can of the technology, but not fitting into the general settlement?
Yeah, that's a great question. And I think there can be two types of splintering off, and I'm not sure which one you're focusing on, but maybe either one will talk. One is physically splintering off a subcone. So splitting the colony apart. People just got so fed up with each other. These people who wear white dresses, they're messing up the colony. I'm going to go form my own colony. That's one thing. And I think that the settlement would have to be about at that stage before people would realistically start to think that way, because you want enough people in your new settlement to survive.
So you think past 1,000 or past 10,000? Where do you think that splintering is?
Let's say 1,000 for that.
Okay.
But the other kind of splintering is more the psychological splintering, where people form little groups and poker clubs, and they kind of form their own little cliques and all. And that could probably happen at any size, even with 3 people. There's an old saying I heard from a guy I worked at NASA named Bill Clancy. He's a good friend of mine at NASA Games. And he does psychology. He does human psychology study. And he says one person on Mars is lonely, 2 people fight, and 3 people gang up. So if you send 3 people to Mars, 2 of them are going to form a little clique and gang up on the 3rd person. So this is part of the interesting psychology that's possible someday, even in very small groups. So very quickly, before Bart gives me the cane. So our total recall Mars, well, for those of you who've seen the movie, you can probably think of a lot of concerns that people had when they were living in that Mars. I don't think anyone would really want to live in that Mars. It was kind of a dystopian Mars, full of revolution and violence, and Arnold Schwarzenegger. So, more can be said. It was awesome. Arnold,
It made no sense.
get your ass to Mars. So these people are thinking about a lot of things, including Arnold. Their own careers, they might have more petty concerns. Really, we're starting, the point here is, I just listed a few things, but who knows? And they're probably going to be concerns that we in society here on Earth have. You're getting to be so Earth-like now, really, in terms of the settlement and the population, that you're probably going to have the same concerns. So, and then, sports, for example. Sports teams. We have some great leagues. You could play great sports on Mars. That's a whole
I'm going for the high jump.
fascinating. Yeah. I will play basketball. Yeah, wham, basketball.
What are grungy bellies?
Belters. Around this stage of Mars, you might have people doing stuff out in the asteroid belt. Right. You could potentially have some exchanges, and these people, if they were doing work on asteroids, a lot of it you'd want to do robotically, of course. But if you actually have people doing things with the asteroids, it might be a little grungy. It might be just coming back from long missions. And, And in fact, with Total Recall, a lot of it was about mining on Mars. That was the subplot of the whole movie, pretty much. So, yeah.
Well, that's Netherlands again.
Can you imagine 1 million people in Netherlands? Ooh, that's scary.
Well, just on ski days.
Or festivals.
Yeah.
Yes, or festivals. And this, we're not even gonna worry about that. Maybe that's what they're thinking about. And this is what my comment was. When I was in an all-day meeting with Alan Stern yesterday, and he was complaining, he had given this fantastic New Horizons talk right after the launch to a group of middle school kids in Arizona, I think he said. He laid out what the mission was and all this cool science that's going to happen and all. And then he got to the end and he had time for questions. And this little girl raises her hand and says, how many people are on the mission? He thought it was such a good talk, but that's what they were thinking. And so maybe that's what they are thinking at this time. And really, that's a great thing to be thinking. We could be sending people to Pluto by then. And I think that's it. Thank you.
Any questions?
Yeah.
That was great.
More
Good questions too.
Yeah. Well, that's
Or
what I like to
comments?
do.
Questions?
More comments. Who would like to live on Mars?
Well, that's what I was wondering.
That's
Yeah.
my plan.
I'll go one way.
Is it one way trip?
Your choice. Your choice. Either way.
So the nuclear power, is that unshielded, partially shielded?
Yes. I think I've heard both options speculated
We
about.
should bury it?
Yeah, burying it. Yeah, nuclear, it opens up some debates. We have the movie, the slide from The Martian. If you remember what The Martian did, that was one of the criticisms of the movie, was he used this RPG and basically unshielded it and just stuck it into his rover and then was rolling around Mars with it. An unshielded nuclear power source. Not very smart. So, by the time you get nuclear power on Mars, I think my answer, I keep coming back to this answer a lot of times, but you're going to have enough people on Mars and they're going to have enough local political intelligence that it's going to be their decision. These technical details are going to be theirs. So really, whatever we want, if they can find someone on Earth to give it to them, because that's got to come from Earth, they'll probably do it. So, I don't know. We had a good talk earlier at the Wonderview Cafe about laws on Mars. The whole legal framework of Mars is a huge open area. And so what are the laws going to be like at each of these settlement stages? Don't know.
May I toss this back to you?
You may. Oh, good toss. Nice.
Here was one.
Yeah.
Good job.
So,
And you're a lefty too. Yeah. Oh.
so would you go to Mars?
Oh boy, I gotta be careful because Lori's.
Yeah, I
know. The joking answer I gave in a TV appearance once was that no, I would not. But if Lori got hit by a bus tomorrow, then I would think about it.
Why don't you just talk her into going with you?
She won't go. I tried. It's, in my book, my crew is a series of different age groups, really. And there are some advantages to sending older people to Mars. But I think really on the early missions, it's kind of a younger person's game. It's going to be a very physically demanding place. So I'm getting too old for that. My back isn't good enough.
Unless you're out.
Maybe you can compromise. Just be like, okay, how about this? I won't go to Mars, but if the kids want to, we absolutely have to let them.
I like that. Okay, so I need to run by Noah. Linda. Oh, that is brilliant. Okay, I've got the plan now.
You can live that vicarious.
So any other questions?
Hey, where are we on your thinking? This is great. Okay. As far as I can see, the moon is going to be the testing ground for hardware.
That's the plan.
That's the
a
plan, but do you believe that? Is there enough momentum in moon exploration to actually try out a lot of these concepts for technology and power packs and all the other things that you have to live on Mars? Is the moon the gateway to Mars in your mind?
I'm tempted to say no if you're only looking at the government side of things.
I didn't say government. I said
Yeah, and I know that's
Yeah.
probably where you're going with this.
Yeah.
When you get private industry involved,
Yeah.
they have a lot more flexibility and they can really research all these cool things, and whether they do it on the moon or somewhere else. You know, strictly speaking, a lot of the research has been talked about doing on the moon into things like this, into living on Mars, could be done right here on Earth.
Yeah.
But will people do interesting things on the moon? They'll do great science. They will be testing some technologies, especially if you get private enterprise involved. So yeah, I can see that. I can see that. If it was NASA only and they were the only game in town, every 4 years or 8 years, everything would change.
It seems like
You wouldn't get very
there
far.
seems like a psychological thing about the moon for humans to be away from Earth, to have long duration on a faraway place. Joanne Hart, I didn't say government, I didn't say industry, I'm saying people.
Yeah.
To do almost the mental gymnastics that are going to be needed to get to Mars. There's a space race, there's just literally a race of people that are going to have to be maturing to be on a long duration Mars habitats and all the colonization. And if you can't do it at the moon, I don't see how the Mars thing, psychologically and technologically, and government and all the other things are going to have to happen. I don't see
I
it.
think you said it exactly right. If you can't do it at the moon.
Yeah.
Yet, that's not really been proven. So we don't
That's
know.
what?
That hasn't really been proven that
No.
we can't do it on the moon.
No.
So,
I disagree, Leonard. Why don't you skip the moon, you just
Yeah,
figure it out
do
with
it.
Mars.
Figure it out.
I mean,
yeah,
Okay,
that's
so I see a lot of
basically the
littered
less diplomatic
bodies on
way
Mars.
of answering what I just
That's
said.
right. I can see a lot
Yeah.
of,
Can't
no
just do it.
littering on Mars with human beings, somehow there's got to be some maturation process.
it's the getting back part, where you can easily get back to the moon and freak out, but you can't get back to Mars.
One of the ways I like to kind of describe it for people, in my mind, this is kind of how I see it. There's some good reasons to go to the moon and all. But if I was going to pick where I wanted to go on vacation and not living and work and all, would I pick the top of Long's Peak or would I pick Fiji? Top of Long's Peak is a lot closer. It's got beautiful views. You can almost walk there, and you can get back from there a lot easier. But it's not really where I'd want to be. I'd rather go to Fiji. It's a lot harder and a lot more expensive, but that's where I want to go. So, I don't know. Yeah, it's an interesting question, and this is one people, especially at NASA, debate forwards and backwards. I don't know. NASA will do what they want to do. Elon will do what he wants to do, and we'll find out. Bezos. Yeah, well, Bezos, I guess like Elon, he's really focusing on Moon and Mars. So actually, Bezos is kind of light on Mars. I haven't really heard him say too much about Mars. Whereas Elon Musk, he's all about Mars. He always has been. You know, I had breakfast with him back in
No way.
2003.
No way.
Ish. And it was just Mars. Elon's a Martian.
Yeah. Any other questions? Okay. Well, so thank you so much. And I just want to say a few other things. Our Skywatchers has a Facebook page that Carolyn Collins Peterson manages, and that's a good place to go look. And eventually our website will be back up again.
I'll get there.
Okay, yeah, we've got some issues with that. Also, Susie had mentioned when you leave, be very careful because it's still a little icy out there. Also, Marion and Wayne are going to Antarctica in a couple of weeks.
2 weeks.
2 weeks? How long will you be there?
The whole trip is 15 days.
15 days? So, yeah, we'd love to have you say a few words about that, you know, at our next meeting.
It's not really
Well,
interstellar.
yeah,
Still
but, you
adventurous.
know,
Yeah.
yeah. And, let's see. So at our next meeting, we'll also have, Carolyn, you'll have your books and some stuff to sell. She's a sewer, so she's got some great star material. She's making some really good stuff. And we'll have a few other things, and John's cards, maybe, although you won't be here, but your Hubble cards, okay? And Dave's cards.
We had a calendar too, I think.
Oh, will you? Okay, and they will have a calendar. And, let's see, so let's, if we can put away the chairs and then come up and do a group picture up here. And, John said it's too cold to be up there, out there. He brought his 12-inch telescope, but, looks like